So the last thing we're going to talk about in our in our polynomials unit is something called the rational root theorem. So in previous lessons, a lot of people have asked, well, what if we don't have a given factor? How would we factor a polynomial? So we're going to go back to our previous example of x cubed plus 5x squared minus 2x minus 24. In a previous example, we were told that a factor is x minus 2. But let's say we didn't know what it is. The rational root theorem tells me that all roots in the real world, all real roots, will have the form of p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. So remember that the constant term is whatever is the number at the end, so that would be negative 24. The leading coefficient is whatever number is in front. In this case, it's actually just 1. So the rational root theorem says that if I take all the factors of 1, which is just 1 and negative 1, and all the factors of negative 24, which is 1, 2, 3, 4, 6, 8, 12, and 24, and the positives or negatives are all of those, one of those combinations or a couple of them are going to be possible solutions. So for example, so all of them are going to be over 1 or negative 1. So I'm first going to put all of these on the top. So these are all possible p's or possible numerators. So, for example, you would have maybe, you would have 1, 2, 3, 4, and all of these are pluses or minus. 6 plus or minus 8 plus or minus 12 plus or minus 24. One of these is going to be your solution. So all of these are technically over 1. We won't worry about writing the 1 for now just because it's the same thing as writing it without it. So the way to check it is using the factor theorem. Remember, the factor theorem states that it's a factor if the remainder is 0. So we won't try all of them, and in your homework problems you won't have nearly as many to choose from. But you would have, for example, you would use synthetic division and put each of them on the outside. So if we tried 2, we would put 2 on the outside or negative 2, and then you would go 1, 5, negative 2, and negative 24. And you would do that whole process of finding the result and finding what the remainder is. And once you got a remainder of 0, it would mean it would be a factor. So to sum up, the remainder theorem states, or sorry, not the remainder theorem, the rational root theorem. And write this one down in your notes. So the rational root theorem states that all real factors of a polynomial are of the form p over q, where p is a factor of the constant term or the last number, and q is a factor of the leading coefficient or the first number. I'm just going to write L coef, first number. So go ahead and pause the video and make sure you write that down. Just a reminder, so when we did over here, we had 2 from the factor and we took 1 from over here. We tried it out, we got a 0, cool. That means that x minus 2 is a factor. So this is another way that I would know x minus 2 is a factor of the equation from before. So then I would go through the process of factoring the leftover quadratic over here. So I would take this and make I would factor that quadratic, and then I would multiply that by the x minus 2, and then I would find what those are when equal to 0. I think on the test, we're just going to ask you to find possible things. We're not going to ask you to actually go through that whole process of testing all of them out. But make sure you understand that this is what the rational root theorem means, and that p is from the last number. So p comes from the constant term, and q comes from the beginning term. So q is on the bottom. And hope that helps with the rational root theorem.